To begin with, the input of fatty acid synthesis is the acetyl coenzyme A is carboxylate to malonyl coenzyme A. But before that, we have to synthesize the acetyl coenzyme A first by condensing the acetate with the coenzyme A. Now, I want to replace these big groups to big R because there is no space left. Oh, this become R, and the lone pair at the sulfur is spontaneously transferred to acetate carbon. The electron shifts and rearrange itself, leaving behind the OH group. Here is the products. Now, dehydration occurs between the hydrogen atom at this sulfur with the OH groups to form the water. So we will take this hydrogen out, and this compound is called acetyl coenzyme. Now we are at this point. In the next step, the reaction is mediated by the ATP and the biotinol enzyme as the carbon dioxide carrier. Carbon dioxide mainly comes from our inhalations. When it's combined with water in our blood, is from carbonic acid, which is this, which will spontaneously proteinate hydrogen atoms, and will give out the hydrogen carbonate ion. This one is called hydrogen carbonate ion. Carbonate ion here will react with the ATP or adenosine diphosphate, which derive from ADP plus phosphate. The bicarbonate ions is then react with ATP. These oxygens act as nucleophile, so the electrons in these oxygens will shift to the strongest electrophiles to this phosphorus, giving out the carbonyl phosphate. Is then catalyzed by the acetyl coenzyme A carboxylase or ACAC. In the this one is called the biotinol protein. So the electrons lone pair in nitrogen shifts to this carbon, giving out the carboxy biotinol enzyme. Now this phosphorus will leave as well, and the acetyl coenzyme A takes place. The carbon spontaneous shifts to shift the electrons to another carbon of the carboxybiotinyl enzyme. Finally, we receive maranyl coenzyme A, maronyl. I've got the O here. The acetyl coenzyme A and maranyl coenzyme A are catalyzed by HS enzyme and HS enzyme, or the ACP. So again, the lone pair of the sulfur will shift to this carbon, and also shifts to acetate carbon here, leaving behind the coenzyme A, and the ACP comes to replace the coenzyme A, which will give this structure. So the coenzyme A is replaced by ACP. Now we can combine the acetyl ACP with the maranyl ACP. In a maranyl coenzyme A pathway, the condensation steps is the covalent linking of the acetyl coenzyme A with the acetyl ACP with the maranyl ACP. So the electrons of these oxygen ships spontaneously shifts both bring and bring to get the acetyl ACP. Later on, this acetyl ACP will be reduced by the NADPH. Now we come to the reduction part. The first reduction steps is the conversion of the acetyl ACP with the beta hydroxyl butyl ACP using the NADPH, NADPH, NADP plus. So this double bonds, the oxygen double bond, will be replaced by the OH groups. The dehydration step is the conversion of this beta hydroxyl butyl ACP to the continuous ACP with the release of the water. So another reaction steps is the conversion of the acetyl continuous ACP with the this one is called butyryl ACP. Using the same things, the NADPH, NADPH, NADP plus, and butyryl ACP was then condensed with another maranyl coenzyme A to start a second cycle. Even though the maranyl coenzyme A is a 3 carbons polymers, 1 carbon is lost in the condensation steps, and therefore only 2 carbons are added to the growing fatty acid chain at each round. So thank you.